going to consume the A. It's going to take us to a final state that we'll symbolize by these double circles, and let's call this S1. Okay. Now, from a naive perspective, this machine at this stage, it does accept the word A. Yeah. But what would happen if we passed other words into this particular machine? We shouldn't accept them. Okay. For example, this machine, if we pass in the word A, okay, into this machine, okay, well, it'll go from S0 into S1. There's no other input to read, so when we consume the A, we've no other input to read. Okay, and let's just say we have a little special character here to signify end of input. And what the machine will do, the machine will then ask itself, am I in a final state? It is in a final state on the consumption of this particular A. It takes us from S0 to S1. And it will return yes, that this particular word is in the language. Okay. Say if we pass in the word B. Okay. And let's say here's the end of the sequence here. Okay. Say if we pass the word B into this particular machine. Okay. Well, the machine is a language. It should recognize a language over a particular alphabet. The alphabet in this case being A's and B's. So the machine should try to read and continually read its input, okay, until it gets to the terminating symbol here. Okay. But what we know is that when we consume a B, okay, well, we're in state 0. When I consume the B, okay, it should take me to a state, but not a final state. Okay, but I should still try to consume the B. Okay, so what I do is I'm going to consume the B, and that's going to take me to another state. Let's call this S2. Okay, so when I consume the B, I go to S2. Okay, right, that's okay so far. Okay, what we've actually done now is you can actually see that we've allowed this machine to only accept on an A, okay, which is this word here in L1. It shouldn't accept on a B, okay. Well, there you go. We've gone to S2, and it's not going to accept. But it shouldn't accept on anything else. It should not accept on any other word, okay, that could possibly be passed to this machine as a sequence of characters. Okay? So, what would happen if we passed in AA to this machine? Okay? Well, we shouldn't accept it. Okay? So I'm going to consume my A. I'm going to be in state 0. I'm going to consume the first A. Is going to transition from S0 to S1. Okay? Now I should try to consume the next A, okay? But I shouldn't go to a final state. So let's symbolize that by going into S2 on an A. Okay? So you can actually see what's happening here. The only time we're ever going to get into this final state here is when it's a word with a single character. Okay? But what happens if we pass in an A and a B into this machine? Okay? Well, let's see. When we pass in an A in state 0, we consume the A, which takes us to the final state. We haven't reached the terminating symbol, okay, so we should try to consume a B. But we shouldn't accept this word because it's not in the language, so let's take this to S2 on a B. Okay? So you can see what's happening here. Okay? Now, at this stage, this machine will still only accept the single character, but won't accept any words of length 2. It won't accept an A followed by an A. It won't accept an A followed by a B. It won't accept a B. Okay. Will it accept a BB? Well, it'll take a B to here. What about a BB? Yeah. Well, what we should do here is this, is that because we know now that all other words along this particular path are going to be of greater than length 1, okay? In particular, they're going to be of greater of length 1 when it starts with a B. Could be of greater of length 2 when it's an AA. So what we'll do is we'll just continually consume, okay, A's and B's, okay, when we're in S2. Okay. I hope this particular example helped to, I suppose, helped us with our understanding of finite state machines. The most important thing that you really need to take away from this particular example is that the finite state machine that recognizes the language A is not just the state S0 taken to S1, final state on an A. It has to also try to consume all other possible inputs that might be passed into the machine itself. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. I will follow this video up with another couple of videos that extend the languages to some more, still very small languages, but getting them a little bit more complicated than what we currently have. Okay.